Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani. I am from Department of Computer Science, Albert College, University of Delhi. So as you all are aware that presently we are learning a topic of database management systems, and within this series what presently we are going to do is about the transactions and transaction management. And in our some of the previous lectures we have seen the concept of transaction, what are the essential properties of transactions, which are nothing but ACID properties, as it atomicity, consistency, then isolation and durability. These four are the essential properties of transaction management, and we have also seen these properties of transaction management into a greater length of detail that we have also that we have seen. And today we are going to look into more deeper into some schedules, or some serial schedules, some serializable schedules which are related to these properties. So we are going to get into greater depth of it. So now coming to in ACID properties, the third property, which is starts from I, is about isolation. So when we talk about the transaction isolation, although if you can see, the transaction processing system usually allows multiple transactions to run concurrently. That means within a database, let's say one particular transaction is going on and simultaneously another transaction is also happening. So what is going to happen in this kind of concurrency or concurrent transaction is, this may cause several complications with consistency of data. So that means let's say two of the transactions are operating on the same database objects. The database objects which I am talking about here is, let's say, accounts. So two parallel transactions or two concurrent transactions, we can say, are going on to take place onto two accounts that are going to cause complications with the consistency of data. How is it going to be, that I am going to cover with an example in a short while. So basically the point which I am trying to establish here is ensuring consistency in spite of concurrent execution of the transaction requires some extra work. So here is basically two, we can say, complementary or two different concepts which are trying to bring together. One is we need concurrent execution of the transactions. Also maintaining consistency is something which is the need of the hour. So ensuring consistency along with this concurrent execution definitely going to requires some extra work. Now what if we don't do that? It is a very easy thing to insist that the transaction should run serially, that means one at a time, and let's say we have two transactions, T1 and T2. So first let T1 finishes and then T2 starts, or it could be other way around, that T2 starts, finishes, and then T1 starts. So running transactions serially is that in which the transactions are running one at a time, each starting only after the previous one has completed. Now if this is kind of a simpler idea, then why we are looking towards concurrency? Now imagine if you are kind of through with the topic of multi-programming in our operating systems. So basically what is happening there, and what is happening there in the multi-programming, is actually the scenario which is going on here. When we talk about concurrency, that means transactions are being executed in concurrent to each other. That is improved throughput and resource utilization is going to be the achievements, we can say. Through concurrency we are going to have an improved throughput, as well as we are going to have a maximum or improved resource utilization, we can say, because a transaction is actually like a complete operating system job which consists of many steps, which consist of many activities. For example, some steps in a transactions require some input output activity, other may require some CPU activity, because we are updating the balance. I am talking about with reference to the previous example of account account updation which we are taking for this particular topic. So if we want to update the account, it is kind of an input output activity. If we want to subtract some amount, or if we want to add some amount, this is kind of a CPO activity. So basically a transaction is having many steps, and each step is involving various type of activities including input output activity and CPU activity. Now what is happening here is the CPU and the disk in a computer system can operate in parallel. So we can easily come to the conclusion that input output activity can be done in parallel with the processing which is going on inside the CPU. So that means we can have multiple transactions in parallel. One step of one transaction is busy doing some input output activity, another step of another transaction may involve CPU processing. So what is happening, rather than going T2 starting after T1 or other way around, T1 starting after T2, this kind of concurrent execution is going to increase the throughput of the system. Also, when we talk about the throughput of the system is increased, that essentially means that waiting time for a particular job or for a particular transaction is going to be reduced, because your concurrent execution is going to reduce the unpredictable delay in running the transactions, and it is also going to reduce the average response time. So delays are kind of we can say reduced because of this concurrent execution, and so is your average response time. So we can say with the concurrent executions we can have reduced waiting time. So here we have established that it is necessary or it is beneficial, we can say, to have transactions running concurrently. Fine. So then what is the problem? We are convinced that concurrent executions are going to give us the benefit, right, in terms of one way or the other. Then what is the problem? So the problem is when several transactions are running concurrently, the isolation property may be violated. The isolation property says one particular a transaction should run in isolation, and it is not going to be mixed, it should not be going to be mixed with the others. When two transactions are running concurrently, the isolation property may be violated, it is a high chance, and then if isolation property is being violated, this is going to result definitely in the database inconsistency, or we can say the violation of isolation property is going to result in the database consistency being destroyed despite of the correctness of each individual transaction. The two individual transactions T1 and T2 both are correct, but when they are going in a or when they are being executed in a concurrent fashion, they may lose their isolation property, and the state of the database is going to be inconsistent because of that. So that means we need to put a check here. Essentially what I am trying to say here is the database system must control the interaction among the concurrent transactions to prevent them from destroying the consistency of the database. I am repeating this sentence again. The database system must control the interaction. We are not saying to stop the interaction. That means concurrency is something which we are going to live with. So we have accepted the concurrency, but that concurrency should be what we can say is implemented in such a manner that all the concurrent execution should be prevented from destroying the consistency of the database, because with the consistency of the database we are not going to compromise. And how it can be done? So your database system does so through a variety of mechanisms, and all these mechanisms comes under the umbrella of concurrency control schemes. So your database is having some kind of techniques, or we can say mechanism or tools through which this concurrency is concurrency is established without destroying the consistency, and that mechanism is called concurrency control scheme. Now let us try to, with the help of an example, let us try to understand what is happening, when two concurrent transactions are being executed. So till this point we have seen that yes, two concurrent transactions are being executed. This may result in the violation of isolation, which ultimately goes to the violation of we can say a violation of consistency. So let us try to understand this whole concept with the help of two examples. Now here let us say we have two transactions T1 and T2. The name of the two transactions are T1 and T2, and both these transactions are there for transfer of funds from one account to another, and the two accounts which are involved here are the account A and account B. Although the transaction T1 and transaction T2 are doing different things onto those accounts. So the first transaction which I am naming as transaction T1 is our usual transaction which we have seen in our earlier examples, that is of a transaction transferring $50 from the account A to account B. Let us quickly go through just for the sake of we can say lack of just to maintain the bridge. So T1 is the transaction in which the account A is being read, whatever the balance is with account A. Next step is about kind of we can say processing, in which the $50 or amount of $50 has been subtracted from the current amount of account A, and then it is being kind of written, the new amount or the new balance is being updated. Similarly, B is being read, $50 has been credited, and the amount of B is also being written. So this was the usual transaction T1 which we have also seen in our earlier examples. Now what about transaction T2? Let's see, the transaction T2 is about the transfer of 10% of the balance from account A to account B. So in this there is a twist, or there is a small change of the calculation we can say. So read A, then we have kind of created a temporary variable in which the 10% of A is being stored, and now A has been we can say deducted by this temporary variable, and the A has been updated through write A. B has been read, and that 10% of the 10% amount of the whatever balance is inside the account A is being added to the B account B, and then account B is being written. So this is the definition of two transactions which we are going to discuss here. So here let us see that or let us assume that the current values of A and B are $1000 and $2000 respectively, and I am also assuming here that these two transactions are executed one at a time in a sequential order, I can say. So which is T1 followed by T2, or it could be other way around, which is T2 followed by T1. So first of all let us see T1 followed by T2, and the current values of the accounts A and B are $1000 and $2000 respectively. So now what is happening here? So T1 is T1 is taking place by read A is equals to A minus 50, write A, read B, B is equals to B plus 50, write B, and please notice the use of commit. That means this particular transaction is being kind of we can say saved, or this particular transaction is freezed in a way. After T1 finishes, what is happening? So T2 is going to begin after T1 finishes, and then the updated amount of A is being read. Updated as in whatever is being updated by transaction T1, that has been read, and 10% of that transaction, then 10% of that amount is being subtracted from A has been, amount of or the balance of A has been returned, then that particular 10% is being added into the amount of B, and then B is also returned, and then finally this is committed. The second transaction also is in a commit state. So, we have performed. So, whatever we have done is we have performed T1 completely, and T2 is going to begin after T1 finishes. Both the transactions are going, serially, that is one after the another, and both transactions are also executing the statement of commit. So, that this is what, one kind of mechanism is. So, on the other hand, if we follow the reverse order says if the transactions are executed one at a time in the order T2 followed by T1. So, T2 first and then T1 second. So, this is going to be the situation in which T2 is read A, temp, calculation of temp, which is 10% of A, then A is equals to A minus temp, updation of A, reading of B, adding of 10% into B and writing of B, and then commit, and T1 is going to follow after T1 finishes. In both the situations which we have seen at this point, the earlier one and this one. So, in order to compare, I am just showing it on the screen once again. So, this is the first transaction, please see this carefully, or we can say this is the first schedule and this is the second schedule. In the first schedule, T1 is T2 is followed by T1, and the second schedule is giving T1 followed by T2. Now, what is happening here? As expected or as desired, we can say in both of these schedules, the sum of A plus B is preserved, and the final values of the accounts A and account B are $850 and $2150 respectively. That means transfer of $50 from A to B, and then kind of transfer of 10% of amount from A to B, whatever schedule they are being we can say covered. The sum of A plus B is preserved, and the final values of the accounts A and B are $850 and $2150 in both the schedules. Now, these schedules are known as serial schedules, in which we can say whatever instructions are being the part of the transactions, the instructions belonging to one single transaction appear together in that schedule, and then it is going to going to be followed by another schedule. So, what I am trying to say here is each serial schedule consists of a sequence of instructions that we are kind of aware of from various transactions. The important thing here is the instructions belonging to one single transaction appear together in the schedule. That means, if you can see on the screen, T2 is completed first and then T1 is kind of starting. So, whatever instructions are which are the part of T2 are appearing together. Similarly, whatever instructions which are part of T1 are appearing together. So, it is not like that. What I am trying to say here is, it is not like that for example, read A, temp is equals to A of 10% of A is equals to A minus temp is being executed, and then some steps from transaction T1 are executed. Then 3 steps of transaction T2 are executed, then whatever is left with T1 are being executed. So, this kind of interleaving we can say is actually not happening here. All the instructions belonging to one particular transactions are appearing together, and these kind of schedules we can say are known as serial schedules. So, in which the transactions or instructions I can say belonging to one single transactions appear together in that schedule. Now, what if two transactions are running concurrently? So, let us say two transactions T1 and T2 are running concurrently, the operating system, now it is the liberty of the operating system that it may execute one transaction for a little while, that means 3 steps or 3 instructions of one transaction, then it performs a context switch, execute the second transaction for some time, and then switch back to the first transaction for some time, and so on and so forth. So, 3 steps from T2, then 2 steps from T1, then again 2 steps from T2 and 3 steps from T1, something of that sort is going on. So, this situation when may occur when we are trying when we are running the two transactions concurrently, the operating system may do that. So, with multiple transactions, the CPU time is shared among all the transactions, because you all are aware that CPU is a kind of faster device as compared to our input output devices, and so there is a possibility or there is a requirement of sharing the CPU time among various transactions. Now, what is happening is, when I am talking about the operating system here, that means concurrent executions are going on and the control of the concurrent execution is left entirely to the operating system between many possible schedules. Then what will happen? This may, or there are, we can say, are very high chances of this thing happening, that these schedules in which the management of concurrency is left entirely to the operating system. So, this may leave the database in an inconsistent state. So, we can see that if it is the responsibility of the operating system, then operating system will kind of randomly pick one particular schedule in which one some part of transaction T1 is happening, and other instructions from transaction T2 are going on, T1 is not finished yet, and kind of some interleaving is happening here. So, with multiple transaction, the CPU time is going to be shared among all the transactions. That is also something which is inevitable, or we can say which is desired also. So, if the control of the concurrent execution is left entirely to the operating system, many possible schedules, including ones that leave the database in an inconsistent state, are actually of the higher possibility. Then the situation comes up, what should we do? So, in this situation, when operating system is in charge of all these activities, this may leave a database in an inconsistent state. Now, here we have arrived at a problem actually, that concurrency is yes required. We have established that in our we can say in our previous discussions, the concurrency is required. And now what are we looking for? We are looking for maintenance of consistency along with this concurrency, and we cannot leave this entirely to the operating system. Then what should we do? Here is a problem. So, we will be covering the solution to this problem in our upcoming lecture. So, in this lecture we have started with concurrency. We understood it very briefly because we have already covered in kind of detail. So, we quickly recapped it, and then we have seen how to this concurrency is to be maintained, and what are the problems in maintaining this concurrency. Solution to these problems will be definitely covered in our upcoming lectures. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.